we're now looking at the scatter. So this is looking at our relationship between our two variables and looking at the amount of scatter over it. So we want to look at whether the scatter is consistent, which means is it the same width across. So we're looking to see, are there any areas that are denser or sparser than others? And at different values on the x-axis, we want to see, is the scatter a similar width for those? So if I look at this particular graph here, this is a graph which has a constant scatter. And so if I was to draw a line around the top and around the bottom, kind of like joining the dots together, so just draw nice solid lines there, and I want to look at low values of x, and that's where I've just drawn my first red arrow. For low values of x, how wide is that relationship? At other values of x, so now I've gone up to the top, how wide is that value, that width at the top? Okay, and I can see there that the width is the same at the top as it is at the bottom, and that tells me I've got a constant scatter. If I look at this graph here, this is an example of what a fan looks like. For low values of x, I've got a small scatter, and you can see my little red arrow there. Whereas in the middle, scatter is increasing. As I go towards the end, the scatter gets even wider. So that's like a fan. It starts off closed, and as you open it up, it becomes wider and wider and wider. So that is a fan effect. If it was the other way around, if it started wide for small values of x and got small for big values of x, then that would be a funnel. Okay, a funnel is an object that starts off wide and gets narrower. So we need to look at our fuel efficiency by weight. And we look at that graph there, and you can see I've added some of those lines around the majority of the data. And if I look at low values of weight, so values are around about 700 or 800 kilograms, then I've got an arrow there showing the scatter is reasonably wide at that point. As I go further along, as I get to about 1,200, the scatter has gotten smaller. And as I get down towards value of about 2,000, so I'm moving to the right hand side of the graph, the scatter now has got a lot narrower. So in this case, we've gone from wide scatter for small values of x to much narrower as x gets bigger. So the scatter has changed here, it's not consistent. So that's what we want to describe. So we can say the scatter on the left hand side is wider than the scatter on the right hand side. And then I'm being more specific. So the scatter for car weights below 1,000 kilograms. So if I just go back to your graph, 1,000 kilograms, okay, the scatter below that is much wider than the scatter above that. Okay, and then this is where I'm telling the story. Can I think of a reason to explain that? So car weights that are below 1,000 might be more spread out because of the small number of cars in that range. Just go back to the graph. There aren't as many cars in that range below 1,000 kilograms. So there's only 1, 2, 3, 4, 5, 6 or 7 values that I can see, whereas above 1,000 kilograms there's a lot more values. Okay, so if I've got more information, my spread of my data is going to be smaller because my accuracy is increasing.